Sir, Selvakumar sir, shall we start, sir?
Yes, sir.
Okay, sir.
Yes. A very good evening to Anand gathered here. It's my immense pleasure to welcome you all for this Day 2 ATEL sponsors 6 days online faculty development program on next generation medical automation, the role of AI and IOMT in transforming healthcare systems. Welcome you all. It's my pleasure to welcome our today's resource person, Dr. K. Selvakumar sir, Assistant Professor, Department of Computer Application, NIT Trichy. Welcome you, sir. Dear participants, as we said earlier, for each and every session we have a group photo part. So all the participants are requested to turn on the camera. Dear participants, I repeat, all the participants are requested to turn on the camera for a group photo session. Dear participants, I request all the members to turn on the camera for a group photo session. Uh, Thank you, dear all the participants. You may turn off the camera. Thank you. No person ever honored for what he gave. The honor has been the reward for what he received. In this way, I would like to welcome and introduce our today's resource person, Dr. Selva Kumar K. He is currently working as Assistant Professor, Department of Computer Application, National Institute of Technology, Trichy-Tamil. His educational qualification include his completed his Bachelor of Engineering from Madras University in the discipline of Computer Science and Engineering at 2002 and completed his Master of Engineering from Anna University in the domain of Computer Science and Engineering at 2006. Completed his doctoral degree from Anna University in the discipline of Computer Science and Engineering at 2016. He has more than 21 years of experiences and he has served in various companies as well as various institutes. He had published more than 53 SCA as well as corpus articles and he is a recognized supervisor at NIT Trichy. And he is also a doctoral committee member for research scholars from various universities like SRM, Anna University and VIT. His honors and achievements includes he has received UGC BSR Fellow during the 2013-2015 and he is a net qualified in the subject of computer science and application on the year of 2005 to 2006. He also qualified from GATE during 2003 and he is also rank holder during his master degree. He acted as a chairperson, delivered special lectures in various conferences and seminars and given invited talks in the various domains like cybersecurity, artificial intelligence, machine learning, data science, IoT, cloud security, data mining and operating systems. His professional body membership includes IEEE, CSI, International Association of Engineers and IST. I request our resource person, Dr. K. Selvakumar sir, to deliver presentations on the topic of precision healthcare through AI and deep learning on this FTP.
Yes. Shall I go ahead?
Yes, sir, please.
Um, Is this my voice is audible?
Yes,
Because
sir, it's
your
clear.
side it is getting low while I'm okay listening your introduction about myself. That's why I'm asking. Is it voices? My voice is okay, audible? Is it
Yes, sir,
fine?
it's audible.
Fine, thank you. Shall I share my screen?
Yes, sir.
Um, is it my screen is visible?
Yes, sir, it's visible.
Now, okay, your voice is okay, very clear,
Yeah.
sir.
Yes,
Thank
sir.
you.
Thanks, you, sir.
Shall I start my
Yes,
presentation?
sir. You can start.
Thank you.
Yeah.
Um, Good evening, one and all presented in this session. Before I'm going to get start my session, I would like to thank the Kungunadu Engineering College Management and Organizing Committee of this Atal FTP program for giving this great opportunity to share this knowledge about precision healthcare through A and deep learning aspect. By the way, okay, my discussion is going like this. First of all, we are going to discuss about what is artificial intelligence. Then slowly we are going to what is down to the deep learning, brief about deep learning. Then we'll go for the comparison between deep learning as well as machine learning. Then followed by architecture of deep learning, and then how this deep learning aspects and AI combined together is applicable in this healthcare area and its various research challenges too. Finally, I'll come up with the references too. This is the way I'm going to discuss about the topic, whatever okay, mentioned in the earlier slide. First of all, I'll start from artificial intelligence. Even yesterday, a speaker might have given some basics about artificial intelligence. Anyway, okay, I'm not going to bore you. If you feel that anything, okay, let me know. You can interact. Actually, this is a textbook definition of artificial intelligence by Stuart Russell and Peter Norvig. Actually, the artificial intelligence is a branch of computer science aim on building machines and software with intelligence similar to us, that means a human being, so they can perform thinking, reasoning, decision making, problem solving, and understanding natural languages like human. This is a formal definition of AI. Sir, is there any informal definition for the AI? It will be very much okay, easy way to understand. It's there. That is machines with mind. Machines with mind. That is an informal definition of AI. That means how we would have, that is, will come up with machines in intelligent okay aspects like the human being. For that, just we are dealing about artificial intelligence. Straight away, we'll go for that evolution of artificial intelligence during 1950s. This word artificial intelligence is that is was coined by doctor and scientist John McCarthy, and thereafter it is okay spread and then that is grown in a different way, and it has come up with different varieties and different programming languages, Prolog, and various aspects of GPS, etc. Then during okay 1980s, the machine learning is come into the picture. Actually, the machine learning is a subset of artificial intelligence. The machine okay learning okay begins to that is flourish the that is the aid of machines. That is, sir, what is the difference between the machine learning and artificial intelligence? Already mentioned what is meant by artificial intelligence formally and informally. Even in machine learning, it's an actually that it's an idea or it's a subset of artificial intelligence to process and will come up with decision making and generic. That is, you can refer the textbook definition. In informal definition of machine learning is it's an one of the okay tool, mathematical tool to analyze and process the data and come up with the conclusion. That is an main okay aspect of machine learning. Then you see here the deep learning. Deep learning is the subset of both artificial intelligence and machine learning. It kickstarts during 2000 10. That is an so 1.5 decades back. The deep learning breakthroughs drives of AI booms. This is what I want to convey. The keyword is represent the number of hidden layers in that particular neural network architecture. The deep learning is the future of artificial intelligence. Even we people are realizing partially about that beta versions and about Chat GPT, Gemini, Google Gemini, and etc. So these are all the examples under deep learning aspects. Even most of the faculty members and research scholars approach various deep learning models to CNN. That means DCNN, RNN, LSTM, even the generative AI models such as large language models, LLMs, transformers, autoencoders, etc. There are a lot of aspects are coming to the picture. And these are all the major areas of artificial intelligence because it's a core aspect. So that I'm focusing a little bit more on this area, and thereafter we'll migrate to deep learning straight away without discussing the machine learning. And parallelly, I'm going to cover it the deep learning aspects too. Just a minute. I'm going to switch off camera. Then see here, these are all the dependencies of AI. Such actually here in artificial intelligence, such is playing major role to finding the solution to the particular problem. There are three types of searchings are involved in this artificial intelligence, namely uninformed search or blind search, informed search or heuristic search, adversarial search or game playing search. There are varieties of searches which is fall under this particular topic. So which has come up with solutions to that particular problem. So among that, it will identify the optimal one. Then, sir, what is the need of logic? There are variety of logics are discussed under AI, such as proportional logic, first order predicate logic, ontological representations are used here to representing the knowledge. So it is similar to the brain aspects. That means how the human brain is recording, that means are capturing the knowledge. Similarly, the computer system has to come up with its knowledge representation with these technologies. That means whatever I mentioned, just now, that is proportional logic, first order, predicate logic, ontologies, everything. Then the middle layer, machine learning. There are three major types of learning techniques: supervised, unsupervised, reinforcement learning. All are just fall under these three major categories. There are so many varieties. Supervised, you know very well of the supervised learning. It is like an classroom environment. The teacher, whatever it is going to thought, that is going to be learned by the students, and they are applying and following the same. And then unsupervised learning through distance mode. That is, the students are going to learning themselves. Then the reinforcement learning is a kind of semi-supervised learning too, and it will having a major two aspects: planning and rewards. I don't want to go for in depth of that. So anyway, the machine learning aspects are to aiding the devices or electronic gadgets to make smart decisions. Planning, it's a sequence of actions. There is a difference between planning and scheduling. Scheduling is planning with the time. That is called it as scheduling. Planning is again sequence of action that leads from initial to goal state. Then the bottommost layers are major applications of this AI domain, that is NLP, natural language processing, vision, computer vision, robotics, followed by expert systems. Then the next will go for three major categorization of artificial intelligence, such as narrow, otherwise also call it as weak, general intelligence or strong, super intelligence, or otherwise also known as hypothetical intelligence. Narrow, otherwise also call it as I mentioned, here it is weak. That means that particular types of AI agents or machines are able to perform well-defined tasks. For example, the coffee maker always going to prefer a coffee. That's it. It doesn't have any sense to come up with cooking of vegetable biryani or sambar, dal sambar, whatever it is. The second one, general intelligence or strong intelligence, that kind of devices or agents able to perform the additional or the requested task as per its past experience. For example, that machine has the experience of how to ride a bicycle, but the machine is forced to ride a bike, then it will ready to do. Then the third one, super intelligence or hypothetical agent, is an that is mesmerizing device. Whatever we are okay, we have seen in our that is Hollywood movies, that robot or the Rajinikanth acted movie Endiran 2. That is Endiran and Endiran 2.0 and North Indian, okay, so that is in North India it is and Ravan, it is an Shah Rukh Khan acted movie. So that kind of humanoid robots are fall under this kind of category, super intelligence. It will take hardly another 2 or 3 decades to reach us. These are all the three major categorizations, and these are all the components of artificial intelligence. The artificial intelligence is not an easy science to describe, but it's an fuzzy border. That means a vague borders which are connecting. Look at here, mathematics are why we need for mathematics. Actually, the mathematics is an one of the important role-playing aspect in this artificial intelligence. Even whatever the topics which I mentioned, machine learning, deep learning, even generative AIs, everything is purely based upon mathematics, along with biology and science. Without this, there is no, these are all the technologies. So mathematics are mainly used to represent the models. How do we come up with the models? Sir, can you tell us some mathematics in this regards? For this, for learning AI, ML, deep learning aspects, you should have need about probability, statistics, linear algebra, then other the Gaussian falsifiers, Gaussian models or something, even other aspects too. That means based upon the environment and the problem solving nature, we can choose our mathematical models. Then computer science, in order to come up with the specific idea to algorithm programs and related hardwares to execution of the same. Philosophy, how do we come up with the justification and that is we are giving our explanations. Psychology, that is human behavior, or how do we interact with other humans and everything. Statistics already mentioned. Physics, it's an one of the aspect which I mentioned. It's in the science. Biology and other disciplines, how our body is working, what way our brain is interacting with other correct organ systems and everything. This is a short summary of the fields of artificial intelligence. Most of the things actually I mentioned earlier. You look at here, knowledge representation, planning, computer vision, reasoning, problem solving, motion and manipulation, natural language processing, social intelligence. Among that, machine learning already we have discussed. Supervised, unsupervised, reinforcement. Again, how these learning techniques are broadly classified. See here, supervised decision tree, association rule mining, inductive logic, support vector machine. There are so many varieties. Similarly, unsupervised learning, clustering, similarity and metric learning, sparse dictionary learning, genetic algorithms, Bayesian here, reinforcement learning, neural networks, deep learning, manifold learning, everything. Then see here, the artificial intelligence, any system that exhibits behavior that could be interpreted as an human intelligence. You know about that picture, whatever I kept it here, Sophia. Um, there are so many robots are exist, but there isn't some speciality in this robot. One of the first robot who got a citizenship in Saudi Arabia, UAE, okay, E. And also it's an humanoid. That means it can understand our feelings, sense, um, right? Even okay, I have a video clip too. Possible. Okay, I can play the video. How that of this robot control the various devices and its functionalities. So camera is doing face visualization, the person, okay, whether trespassers or authorized person pass.
I know.
Hi, Paul. How are you today?
Fine,
Loudspeaker,
thanks.
also
Are you
text
ready to do some
recognition
work
and
this
everything.
morning?
Tooth
Sure.
recognition too, NLP. So it's a choreography program, mission, okay, the software for walking style and other things. The Wi-Fi, infrared, Ethernet, everything. So object detection, okay, whole body motion to capturing the object. See,
Catch it.
command is catch it.
Too easy, my friend.
Come here.
Listening sound localization, where the sound is coming from. Accordingly, it will adjust and it will do its choreography based walking.
Try again.
That's not really funny.
Yeah, I'm impressed.
It didn't hurt.
So this is an okay a simple video clip about how the robots are okay accepting our commands and proceeding okay its task. So it's an okay everything is controlled by computers. Even you know about pattern matching. Google can decide what okay website you watch. Similarly, the YouTube can decide which kind of videos we can watch. That means they are actually narrow downing our searching and seeking aspects in the internet, right? Somebody okay done this annotation. Okay, I do one thing. Sorry for the interrupt. How do I okay remove this annotation? Somebody done okay annotation here. I have not done. Is it okay? Are you looking this annotation lines? Okay, right. So the mobile can uh, decide to change your contact number in future. Okay, that information. Okay, what kind of information would like to delete? And Amazon. Okay, you know about Amazon. Okay, Alexa and kind of things. See here, this is a tree representation of AI, okay, disciplines and its applications. Here, the branches are represent the major applications of this artificial intelligence. that the trees are represent, that is branch, it's representing applications, and the roots are representing the various aspects which you already discussed under the components of AI. Okay, the straight away will go for deep learning. Already I connected the link among these various aspects, AI, machine learning, and deep learning. Actually, the deep learning is a branch of both AI and machine learning, which is completely based on artificial neural network, ANN. The neural network is going to mimic the human brain. So the deep learning is also a kind of mimic of human brain. Already mentioned what that the deep word is deep, which is represent, where the deep represent the number of hidden layers which is present on that particular deep learning model. This is what mentioned here. So the deep learning is that the deep represent the number of neurons among the layers too. See here also we can call it as deep neural learning or deep neural networks. This is an that functional representation of deep learning, how derived from the artificial intelligence and machine learning, and then followed by deep learning. So actually subset of machine learning make the computation of multi-layer neural network feasibility. You look at this how the human brain, the basic units of human brain, it's a neuron. The neurons are artificially mimicked. This is an artificial neuron. See here, what are the major components? Nucleus, dendrites, soma, cell body, axons, and connecting with the other neurons. Similarly, see here the set of see here neurons which are connected and with another neuron, and it is going to interact with other neurons further. So each and every neuron has its weight function. Biologically speaking, we people are using salt, that means NaCl, sodium chloride. So it is but it's more, and it is going to give an more connectivity and the sense, that is called as weight. It is going to take about that particular cell or that neurons input. If it is the weight, that signal is greater than or equal to some functionalities are given. So accordingly, it is going to fire. See here how the human brains are mimicked. Actually, our brain has an important component that is called it as auditory cortex, which is going to merge both our visual information as well as our hearing information too. Sir, what about the that physically that means the blind people or the deaf people? So that case, it is going to recognize from any one particular sensor, it seems, either through the ear, and it is, or either from the eye. If both are, it is working fine, then it is going to merge together and it will come up with the right decisions and learning based upon the auditory context representation. See here how that is the blind people can walk. You know how the bats are dealing. The similar way it is dealing. See the difference between the machine learning and deep learning. The first field, that is that first column, is completely deal about machine learning. Actually, the machine learning is works on small amount of data set for the accuracy, but the deep learning works on large amount of data, because nowadays there are a lot of sensors, and every smartphones are connected with the internet. So it is generating big data, so no problem in that case. And it is in machine learning, it depends on low end machines. Even we can run those machine learning models in our low configured laptops and desktop too. But deep learning aspects, we need an heavily dependent high end machines like high performance computing, GPUs, Google Colab kind of environment. And also in machine learning, it divides the task into subtasks, solve them individually, that is locally, and finally combine the results together. But here in deep learning, solve the problem end to end. The whole problem is going to be processed in parallel manner. And then here it takes less time to train, the reason behind this, because it has small amount of data. Here it takes longer time to train, but the testing time may increase, depends upon the data and the number of parameters, that means features, etc. But here the less time to test the data. Once the models are get trained. Look at here, how the machine learning aspects are identifying the detecting that object. We are explicitly processing the features. What are the features? Car means, it's okay, four wheel. Even the heavy vehicles also having four wheels, and that width and okay length of the vehicle and the front mirror, okay, front, okay, rear lamp, that is front lamp, everything, tail lamp, everything is going to okay structure, height, everything is going to be considered. But here in deep learning, we are not going to explicitly passing the features of that particular image. Image is going to be entirely processed so that it is going to consider the three levels: the low level, medium level, high level. The low level completely pixel values, dark and that is bright pixels. Thereafter, and the middle level, that is medium level features based upon the that is region based, and even that is what is that size of the tail lamp, regions where it is that headlamp, and what is the size of that indicator, and mirrors, side mirrors, then wheel base, everything is going to be processed. Then that final, okay, that high end is going to be in mirror size, and width of the vehicle, height of the vehicle, length, everything is going to be considered. This is the way the deep learning models are going to process and come up with the conclusion. This okay screenshot, that is image, is going to cover the difference between machine learning and then deep learning too. So I don't want to discuss about this. Straight away we'll go for inside that deep neural network. Actually, the deep neural network combines multiple non-linear processing layers. Actually, it's a simple elements operating in parallel and inspired by biological nerve system. Actually, it consists of three major layers, such as input layer, output layer. In between the input and output layer, there is an enormous, there is a number of hidden layers. Actually, the layers are interconnected via nodes, that is call it as neurons, and each hidden layer using the output of the previous layer. So that is the number of hidden layer calculations, or it is completely black box. How many number of neurons we have to keep, how many number of hidden layers we have to keep in between the input and output layer. It is very difficult, but we can decide the number of input layers. That is how many number of features are we going to process. Based upon that, we can keep the number of input layers. Similarly, the number of output layers, that is depends upon the number of outputs. Suppose it's a binary class, yes or no, 1 or 0. In that case, we can keep 2 output layers. Okay. So next, straight I will go for how the deep neural networks are learning. Look at this. There are that is various components of this neural network aspects. It's an input image. There are a variety of convolutional layer and ReLU, that is rectified linear units. There are variety of rectified linear units. Then pooling, okay, layer, pooling max layer, and then followed by one more, the decision making layer will come into the picture. That is an output layer too. See here, this is an image where the image contains one of four different categories of the object, and we want to the deep learning network to automatically recognize what kind of object it is. Either it's a flower or what kind of object. It's a vehicle, anything. So using that training data, whatever we train. So see here, whatever I mentioned, it is going to process that data, input data in that three aspects: low level, medium level, high level. So each and every layer in the network takes the data from the previous layer, whatever I mentioned in the earlier, which is going to take it, transform it and process to the next layer. And the network increases the complexity and the details of what it is learning from the layer to layer. So initially it is going to learn pixel wise, thereafter region boundary wise, then colors, everything. Finally it will conclude it's a flower. So this is a way it is learning. Already mentioned, suppose it's a face recognition system which is dealing about deep neural networks. Look at here how the face recognition is processed. The raw input is processed in a low level. See here where the high resolution pixels and the dark low resolution pixels are going to be processed separately. Then middle level features, see here, regions. I mentioned about eyebrows, and then okay, our eyes, nose, our okay, mouth, then chin, everything is going to be processed separately based upon the regions. Then the high level, okay, see here, our face gesture, shape, structure, everything is going to be processed. See here. So the number of layers which is dealing about all this, and it will come up with the conclusion. See here, the learning algorithms of how much, okay, see here, 30 exaflops. That is, we are still dealing about TB, terabytes. Thereafter, okay, exa, feta, and then okay, followed by exa, that is exaflop and everything. 30 GPUs, okay, per day which is processing this information. This is traditional and deep learning, okay, networks here. That simple neural network has only input layer, one single or a few hidden layer and followed by output layer. But the deep learning neural network has multiple number of hidden layers. Okay, so sir, how do we fix this number of hidden layers? Only option is we can come up with the trial and error basis. According to our result aspect, we can increase or decrease the number of hidden layers as an only possibility. That's what these kind of technologies are called as black box based aspect technology, because we doesn't know about that internally how far it is happening. There is no specific standards for fixing the number of hidden layers and number of neurons, everything. Only trial and error basis we can, like our TV remote. We doesn't know what technology it is. While you are pressing the button, power button, TV is going to switch on, right? So similarly, we people are using this uh, technology, that is deep learning aspects. See here how it is dealing convolutional. There are variety of deep learning aspects: CNN, RNN, LSTM, and so on. The CNN is convolutional neural network exploits spatially local correlation by enforcing local connectivity patterns between the neurons of adjacent layers. Actually, the CNN is helpful or applicable on the text and numerical data kind of things. Then, okay, see here, CNN is inspired by visual cortex, and also it's in deep nets that are used for image, object, even okay, speech recognition too. So, which is pioneered by Jan Leeken. Deep supervised neural networks are generally too difficult to train. Actually, the CNNs have multiple types of layers. The first, okay, of which is convolutional layer. Look at here, convolutional layer and everything. How far, which is dealing. Already, I told you each neuron has its some weight. So even that fixing of weight also going to be assigned or fixed according to the input or environment. Randomly it is going to be fixed, but after that the weights are going to be fine tuned as per the output of the particular layer. So you see here a series of filters forms layer. Look at here, there are three types of colors here: red, blue, green. So the reds are okay on particular filter layer. Then blue neurons are going to be formed in another layer. Green is another layer. So the layers are going to be formed in such a way, and it is connecting with each other and dealing all computation aspects. See here how the convolutional layer is working. Already I mentioned weight and input layers, then convolutional layer, pooling layer, fully connected, and softmax layer. So this convolution layers are going to process the weight and inputs with that K future maps. Then the pooling layer is going to get trained. That is okay. All are okay. It is fully connected with the you see number of fully connected. That is pooling layers are fully connected. That means each and every neuron from that particular layer is going to be connected with all other neurons which is existing in the adjacent or the next layer. That is called it as fully connected layer. So all are which is gathered together as an hidden form. Then finally the softmax layer is going to mapping that result with a particular specific class. Actually, this CNN convolutional neural networks are okay multi-layered, already mentioned. So that is an okay convolutional layer responsible for filtering the input image and extracting the specific features such as edges, curves, colors, everything. Then pooling layers, here it is there, pooling layer. The convolution layer already mentioned, it is doing always filtering mechanism. Then the pooling layers improve the detection of unusually placed objects. For example, here face. Okay. There is an after detecting this, that is processing this image, it will come up with the conclusion of whether this image is male or female. That is an categorization, so that it will identify studs, long hair, everything, whatever it is given. So normalization layers improve the network performance by normalizing the inputs of the previous layer. That is the purpose of normalization layer. The last one, it is fully connected and then softmax. These layers are neurons have full connections to all activations in the previous layer, similar to the regular neural networks, so that it will come up with the final conclusion of what image it is, like that. Look at this. How the layers are connecting with others, and finally come up with the classifications here. Input layer, convolutional and ReLU, rectified linear unit, pooling, then convolutional again. That number of layers are repeated here. Then you see the classification of the softmax layer fully connected with all together. Then see that softmax layer is holding all class labels. With that, which one is maximum, which is going to be calculated, with that which is going to come up with that results. Next, we'll go for RNN. Already mentioned where we have to apply CNN, images, text, even speech, content, and everything. RNN stands for recurrent neural network. Actually, see this, which is developed by brainchild of see this Jurgen and Sep. Right. Et al. And see here, RNNs have a feedback loop where the nets out is fed back to the net, along with the next input. That means feedback based neural network, and also which is useful whenever the data is in a time series based. For example, every minute data is going to be taken, particularly the climate prediction and all. We cannot expect the same data on the every time series, that is time interval. In that case, that recurrent neural networks are applicable. So the variants of recurrent neural network is LSTM, long-term short memory, LSTM, long-term short memory, LSTM, long short-term memory otherwise. So this, look at this long short-term memory. You might have heard about circuits in the COA or digital systems. That means the two variety of circuits, sequential and combination circuit, the circuit with memory. So you see here, LSTM can learn very deep learning. The task requires memories of events that happened thousands or even millions of discrete time steps ago. So which is memory cells that is hold the previously that the past information about that particular aspects. Right. These are the very popular CNN models during this particular year. LeanNet, AlexNet, VGG, even ResNet, YOLO, various aspects. These are all the various pre-trained models too, regarding whatever which is mentioned in this slide. See just AlexNet, GoogleNet, ResNet, VGGNet, Inception V3, and its corresponding models. How many max pool layers, convolutional layers, and exactly which is existing in this in between input and an output layer. Then this is a computational complexity. We need already it's an high performance computing devices like a GPU, graphics processing unit, and we see that comparing complexity of AlexNet, Inception, whatever you see here, how much that informations are taken, and other aspects too. Memory. These are all the working procedure of deep learning. That is, understand the problem and check feasibility for deep learning. Already mentioned when we have to go for deep learning. If the data set is too big and we have enough computing resources, that means high-end resources, we are expecting accuracy on more and quick fast computing in the result, okay, decision making, then we have to go for deep learning and identifies the relevant data and prepare the data accordingly. Then they choose the deep learning algorithm, whichever is suitable or applicable or according to your data set, training the algorithm and test the model and fine tune the performance. Look at this, the diagrammatical representation of that deep learning model development cycle. See here, the data scientist who gathering the data and they come up with that data and okay model. Then the model is get trained and it's going to be applied on the real-time environment. And based upon that feedback, it is going to be fine-tuned. Then finally, it will come up with the classification, detection, segmentation, everything from the real-time environment. Okay, even you might have seen nowadays, most of the signals are applied speed detection devices. Once if you are passing to the cross, that is passing to the signal, that there is a display which is showing your speed. So that is completely based upon this deep learning models and the okay other aspects. These are all the advantages of deep learning. Best in okay class performance on problems, okay, reduces a need for future engineering, eliminates unnecessary cost, identifies defects easily that are okay difficult to detect, and these are all the advantages. Disadvantages: large amount of data is required, computationally expensive to train, obviously the number of epochs are more, and no okay strong theoretical foundations, requires a good understanding of how to model the multiple modalities. Multiple modality means that is if we are going to process text, video, audio, graphics, everything all together, that is called it as multiple modalities. Okay, so these are all the okay research and application aspects of deep learning. Mainly medical research, precision agriculture. This is what I'm doing currently using these aspects through okay, with my scholars. Then bioinformatics, educational research and application, psychological research, neurological research, then therapeutic okay applications and everything. But so mainly we are going to discuss about medical research. See here, deep learning applications under okay medical we are going to actually the artificial intelligence and medicines and okay it's a part. See here the virtual branches. That means even we no need of that is required physical presence of doctor. That means expert systems. There are okay three types of machine learning algorithms which are already mentioned. Anything we can apply while we are developing such kind of expert systems according to the applications. Mainly supervised and super these three algorithms playing vital role. See here that machine learning, that is also called as deep learning, mathematical algorithms that improves the learning through experience. See here how even okay nowadays we don't need to wait for 24 hours to come up with our reports while we are going for diagnosis. Straight away we are dealing about smart devices for measuring our pulse, heart rate, heartbeat, even our sugar rate, blood pressure, everything, right? How those components are developed with these technologies, right? This is what, okay, we are going to discuss further. So what makes that, okay, healthcare, okay, okay, different? See that, so often see here, often very little, okay, labeled data that, for example, clinical, okay, natural language processing, the doctors are using that mainly, okay, English here, but most of them are, okay, something, okay, natural language processing motivate semi-supervised learning algorithms. Then, okay, sometimes, okay, small number of samples. That means that may be in rare diseases. So it has only a limited amount of data. Even, okay, see the model, the problem, it's carefully for such cases because we don't have get that much of data. It will be very difficult to train the models too. Then lots of missing data, varying time, okay, intervals and censored labels and everything. Even difficulty of okay, identifying the data, need for data sharing agreements, and particularly, okay, even my scholars are facing lot of issues for getting ethical clearance to access and that is process the patient data. So that we are using some simulation, that means models, even generative AI models to come up with the data based upon some sample records. So difficulty of deploying the machine learnings if the data is very less. It's a large data set. Obviously, we'll go for deep learning aspects. And you see this, even that is a survey, President Obama's initiative to create an 1 million person research cohort, the core data set, baseline health exam informations. Um, Even you see this diversity of digital health data set. How do we label the that is lab tests, social media informations, imaging, videos, and see this genomic and everything. And industry interest in AI and ML healthcare, it is booming up, and they are come up with a lot of new ideas, innovatives, particularly in, I don't know how many of you are aware of it. Google Lens, I don't know how many of you heard and aware of it. The Google Lens gathered all our that is retina scan. They are tie up with our Shankara and other eye care Agarwals and other eye care hospitals. They are scanning globally, and based upon that, the Google Lens is going to get trained, and it will come up with disease predictions or what is our body conditions in future. Similarly, IBM, and there are so many international that is corporates are involved in this, that is healthcare aspects. Particularly, you see this in this situations, emergency cases due to limited resources. During the pandemic, the people are suffered to get the bed and even oxygen, those kind of things. So that they are incorporate artificial intelligence and machine learning in this healthcare. Particularly data in emergency departments, they must have required all this data in available form for processing. Right. So generic flow diagram, how the healthcare sector is dealing about this data collection, mainly hospital data, the electronic medical records from the laboratories, cloud data sharing, and it is going to be processed, data pre-processing and model selection through the natural language processing and even machine learning or deep learning aspects. Then the model is going to be trained. See here, either actually here mentioned, one decision tree, all are machine learning aspects. The last one, deep learning. Even nowadays, most of the applications where incorporates deep learning models. That means generative AIs, even explainable AIs and everything. These are all the generic flow diagrams how the deep learning models are dealing this healthcare aspects. See here one after another. So first you go for improve accuracy of diagnosis, prognosis, and even risk prediction and everything. So actually it is going to dealing about all this based upon the data, how far it is going to be. See, improve the accuracy. See here, that risk prediction and visualization is maximum, which is dealing about this. See what all the disease it is going to be. For example, the symptoms of corona, saliva, breathing issue, even cough, sneezing, kind of things. It may be a symptom for a normal fever too. So we have to be very keen on this, predicting what kind of disease it is. So predictive hierarchical clustering, mechanisms we can apply. Even hierarchical clustering of things. So many aspects we can do. Next one, optimize the hospital process, such as resource allocation and the patient flow, everything. So for this, what is that number of beds availability and what kind of disease it is going to be, prediction of futures, how that disease is going to get affect. Even that variations are formed in corona, that is in the virus, and the wave 1, wave 2, we are facing a lot of issues, right? So next, see this, how this automated detection of relevant findings and everything. See here, how the cancer cells are going to detected, automated detection of relevant findings in pathology, radiology, that means skin-based diseases, everything. You see this, the classification of some diabetic aspects. See here, it is going to process our eye retina, and it will come up with okay, what is conclusion of, is it normal, mild, or moderate, severe kind of things. It's an okay decision. See here, normal, mild, moderate, or severe, based upon our data collection. So only that is going to process retinopathy from the retinal fundus images, and it will come up with the conclusions. See how that particular system is working. Input and background, segmentation, everything already whatever I mentioned. Feature extraction, if it is some machine learning, features are going to be extracted explicitly. Then otherwise, if it's a deep learning, then it will go for that is indirect representation of the features. Normal is here. Abnormal, then it is what is the mild, moderate, or severe, it is going to be classified. Then the detection also is available when the key patterns of interest are discovered by the integrating information across many patients. These are all the key advances. One, that is very efficient, accurate search over sub areas of image. Then second one, use hierarchy to search multiple resolution. Okay, right? And then, next, discover new medical knowledge, that is clinical guidance, best practices, and everything. So for that, see how we'll come up with best practices and everything. Next, identifying the patients, subgroups, and which category of that disease it is. Everything is going to be considered. See, diagnostic decision support system, identifying the patient subgroup. Suppose that diabetic is come into the picture, then automatically it will damage all the organs of human body. Slowly it is going to get affect our digestion system, that is even mainly our kidney and everything. So then it is going to identify some groups where it is going to be. Then there is an enabled connected health informatics, which is dealing about here heterogeneous hardware component, GPUs, field programmable gate arrays, and other aspects, which is dealing about automation, accuracy, and consistency with this artificial intelligence and the radiology. You know about it's one of the important field in the medical domain to dealing about cancers. Okay, right? So see here how far it is. Automatic detection and measurement of image featuring in bio markers, the analysis of coronary and peripheral vessels and everything, and even integration of X collaboration detection and quantification. See here, pathology, skin, and other things. Even I've already mentioned that how the radiology is very much helpful. Even it is healing the tumors, brain tumors, and even breast cancers, everything. So for that, we are going to apply, what is the impact while we are going to misusing this, or the normal cells which get affected by this radiology chemotherapy. So that is the hair loss and some various side effects. In order to overcome that, we are going to use artificial intelligence for radiology, for dealing all this kind of tumors and everything. Even medical imaging, see here, invasive visualization of internal organs, where it is that CT scan, ultrasound images, MRI images, everything going to be see here, EEG, ERG, UOG, ENG, EGG, everything is going to be signals, biosignals, which is dealing a kind of signals, that is our heart signals, even brain signals, everything. So look at here, the use case which is dealing about the ultrasound image of that particular problem. Right, see here the tumor tissue characterization using ultrasound, how that image is going to be processed, and it will come up with that decision making using deep learning model. See here, so which is going to see use of robots to deliver treatment and robotic surgery, everything. Even already mentioned, in future we don't need to expect the surgeons to physically appear. Instead of that, AI trained deep learning models are going to guide the doctors to do the surgery. Even use of robots to monitor the effectiveness of the treatments and everything. Passion, you see this care robot. See here in between this. The remote care human actors. It is interacting the human, and it will gather the information. And the success, you see this mammographic mass classification, brain, okay, lesions, airway leakage. These are the various aspects the technologies are incorporated, and it is dealing. Even one of my research scholar who is dealing about Down syndrome prediction using deep learning models. Actually, I thought of to discuss, but those works are communicated recently. So waiting for publication, so that I'm not in a position to discuss those ideas, but I can orally convey the earlier Down syndrome predictions. You know what is mean by Down syndrome? That means if the fetus is formed in that is mother's that is uterus, then the placenta, how far it is going to get affected or lengthy. So based upon that, if that placenta will be okay, right, fell down, okay, or more long, then there is an issue. So that, okay, that is called as Down syndrome. That is going to be predicted. So what will happen in that case? That a baby is okay, behaving like an immature, and is not in a position to stably, okay, stand and deliver, and their hands and legs are going to be shaky, heads also going to shaky, not able to speak properly. So these are all the various issues. So we are predicting earlier that kind of diseases. And even another scholar is dealing the same deep learning models in the precision agriculture domain too. Uh, these are all the various success under this. Then these are all the medical imaging open data sets. Already the Kaggle providing a lot of open data sets, lung cancer, skin cancer, even breast cancer too. Even that whatever I mentioned earlier, Down syndrome aspects. Even my scholar gathered from the hospitals in CMC, SRM. So thereafter we fine-tuned our models, everything. You can see skincare data set, and then other medical image analysis aspects are given. Please, you have to note down, and you can use it for your research purpose. Even you can apply the existing models. Before that, you should know the fundamentals of that is deep learning, machine learning, and artificial intelligence concern, where we are going to, that is, you are going to apply, and what kind of result are you going to expect. Everything is very much important. These are all the other resources just very much helpful to you people to practice these kind of platforms. That is CR Unit, DL, medical imaging, survey, TensorFlow, okay, and then deep learning, okay, see deep compression papers, even CR, Google Colab, etc., Keras, everything, right? And additionally, the data science is an recently, okay, just that is one of the hot keyword that people are very much, okay, preferred in this. The data science, okay, look at here how that the data sciences form. It's an, you see here the combination of computer science, the domain science, statistics, uses software engineering to enable, okay, domain, okay, see domain science to maximizing the use of data. Actually, it's a combination of statistics and computer science, okay, work together, and you see how both are clubbed together and come up with the data science. Look at here, only statistics and computer science both are, okay, clubbed together, and it will come up with the data science. That means we're just analyzing the data and come up with the conclusions or decisions or predictions, whatever it is. That is, okay, applicable here. It is in computer science, viewpoint, algorithms, whatever we have discussed. The statistics, mathematics already mentioned. Computer science, whatever I mentioned, AI, ML, deep learning, even generative AI models, explainable AI put together, which is fall under data science. This is what the essence of data science. How come the data science? There are so various aspects under data science. I don't want to go for in-depth of the data science. Right. The machine learning already mentioned. See here how that, okay, it is going to be applicable on the, okay, layer by layer, according to the specific domain specific, either it's an medical domain, healthcare, or precision, that is agriculture aspect. So it is going to, okay, identify the particular problem, and already mentioned the life cycle of the deep learning model. The similar kind, predict the problem and that required data set. According to the data set, you have to come up with the conclusion of either are you going to apply machine learning or deep learning. Okay, so these are all the major challenges you are going to face during that aspect of applying this deep learning models or any artificial intelligence techniques on the real-time scenario. Mainly the data challenges. Getting the data, even sir, it is freely available, but it is not relevant to our domain. Even you see whatever the Kaggle data sets are which is freely available, those benchmark data sets are only applicable for training the models. Exactly, if you would like to come up with your specific models, then you should need an clear-cut data. So the data collection is a big challenge. Even the research perspective, the researcher who is that is plan to solve a particular problem, he or she must have contribute half of the research career on this data collection part itself. Thereafter, learning challenges. What kind of learnings, that is applicable on this particular aspect? That is important. So the learning challenges, either it's a machine learning alone, it is okay, or deep learning alone is okay. Again, in machine learning, what kind of technique, either it's an supervised learning is suitable or unsupervised or reinforcement learning. So we have to decide the learning aspects. So learning challenges, then spatio-temporal data. That means spatio means that location based, temporal time based data. Then sparse data, missing, noisy data, various aspects are impacting. Sorry for that. Making an impact on our research. So we have to be very clear about this sparse, missing, noisy data. So that we need a data pre-processing. I don't know how many of you approached a data mining concept, which is covering all this. Even the feature selections, because again the dimensionality. There are a lot of that is multiple dimensionalities are there in the data. So it is very difficult to manage. So we have to come up with that dimensionality reduction and take part of the data, and we can okay choose the data accordingly. Then multitask learning, already mentioned, that is even it is doing multitasking, prediction, classification, even grouping, everything is there. So even it is fall under it's a multimodal aspects, which is dealing about multiple data, and it will come up with the multiple results too. These are all the major challenges, mainly on the data collection, learning methodologies, then what kind of data, spatial based or temporal based, that is region based or time based, and then is it the data is sparse data, missing, noisy, everything. I don't want to go for in depth of each and everything, so that only I recommended the participants to refer data mining aspect to come up with what kind of data it is. Okay, so these are the roles of deep learning aspects. See here, deep neural networks, and already we have discussed about this hidden layers and the physical models which we have discussed. And there is a spatial data, whether it is that region-based data we can. That means in India, particularly South India, how many patients are get affected during Corona, and how many of them are taken that, that is for the treatments, and even that corona that is related right vaccines, what kind of vaccines are they taken, everything is going to be spatial data. That is high dimensional, even just dealable. Then multitask learning, see deep neural networks, which is dealing about tasking, informs latent futures and everything. I see here how the missing data is going to be filled. Even we'll go for GAN models, that is generative AI, examples, generative adversarial network based, that is generative process to fill those missing values and everything. Even these are the other applications already mentioned, the crop identification, precision agriculture, disease detection. This is what okay we are discussed under that is health care, image segmentation and clustering, grouping, what kind of image it is, then cloud detection, even that okay practice okay see classification, remote sensing, where that landslide will come, okay that weather predictions, nutrition okay deficiency detection from the newborn babies, even that any okay particular gender, even okay environment classification, is it that the environment is suitable for um, agriculture cultivation or living, or what kind of environment it is going to be. Like that we can apply these deep learning models and everything to the these various fields. um, that's all about discussion. So for any queries, any clarifications, any clarifications?
Dear participants, if you have any questions, kindly unmute yourself and ask the resource person.
Yeah,
Any
good
questions?
evening, sir.
Good evening.
And myself Mr. Lakshmi, sir, from Sasana University. So I'm doing research in IOMT, sir. So
Hmm.
can I explain how the intrusion detection system is affected in IOMT nowadays?
Intrusion detection system, actually, it is one of the major part in the networking aspect. That means
Yes.
um, how, particularly in this domain, medical domain, the fake informations or something that is that molecular aspects, or something that may going to get affect the patient's data, or how that fake informations are going to be okay. Get affect your model. For example, you know that model is well trained, it is capable of detecting the disease in accurate manner. Suppose that model is connected with the internet, how that the intruders or the attackers able to damage the system through their data. So that only okay you have to take care. And is it that informations are true, or okay it's a fake, or from whom you are receiving those informations, you have to be aware of it, and then you can allow. Mostly those kind of devices are not connected internet. Those are dedicatedly it is going to do only that database is going to be upgraded, right? So intrusions are okay not possible, and mainly this kind of domains is what
Okay,
my
sir.
uh,
Yeah, okay.
this uh, anything, any other clarifications?
So may I have
Sorry, your voice is
may
not
I have a
audible.
question, sir? May I?
Yes, we are audible. Yes, proceed.
So may I? So actually, hi, sir. Yes, sir. Sir, actually, I had a quite quick doubt, sir. This is regarding in same what we were discussing in
Sir, your voice is not audible. Can you
Manindan
text the
sir,
query?
is it
integration of
possible you
IoT.
can put the query in the chat box also?
Sorry, sir. I got this bad network. Am I audible now?
Yeah,
Ah,
it's
yes.
audible, sir. Audible,
Ah,
sir.
yes.
It's clear, clear.
So actually, sir, so this is maybe I really want to see how you are thinking, sir, because so I'm working with a bunch of students who have a good knowledge on integrating an IoT with an AI, but so
Hmm.
we currently working in a fields like textile and automobiles, sir. So what is
Yeah.
happening? We will be having an one model which is an input output, which will detect in any quality compliance that will be recorded and that will be trained in a serious time of period, and we are giving an one output of what is getting wrong. So we are currently using in a textiles and automobiles. So I just want to know, being a mentor, am I guiding a students to right way? Because we are just going hackathons. We just applied Smart India hackathons and other hackathons. So being an academician, what is your thing of guiding a students in the field of AI, integrating with IoT, applied fields? How you think, sir? So what we really want to focus? Do we have to train the models again and again, or do we use open sources, or what is your methodology you do to take it to the next level of startup this idea, sir?
Okay. Thank you. Actually, we no need to train the our own model. See that at least depends upon the problem aspect. See, if it's a very confidential problem, size sensitive, then you have to come up with your own model based upon the data, and you can train, and then you take actually whatever I'm narrating as of now, that is, it will take time. But if you are going to use the existing models, you can easily come up with the solutions much quicker way. But the reliability is a question mark. How get that models are trained? So you can choose that model according to the data set and environment. This is what my suggestion, which is machine learning either, or it is a deep learning, whatever it is. You have to other of that particular problem and its problem nature, and where that is that model is going to resolve that. And accordingly, you can suggest your student to choose, and ask them to act accordingly. That's it.
That is very clear, sir. So, being an like academician, we just have an idea of hackathons, maybe a project. So, any other fields that we really want to try this vertical, sir? So, where we can go and experiment to. So, in perspective of startup. So,
See, there are a lot of that is openings. What you say? Openings. So you can apply not only in this textile and that is automobile field, even precision agriculture you can focus, even smart cities, smart transportation, everything, even sustainable energy development, environment, everything. Okay, you can apply. So these are all the hot areas you can focus on the particular domain. Thank you.
thank you so much, sir, for your patient answers.
Thank you.
Good evening, sir. I'm
Good
Dr.
evening.
B. Shobha, professor from PSN College of Engineering Technology.
Yes, ma'am.
Actually, our students are doing the project related to the diabetic retinopathy, sir.
Okay, madam.
Actually, they developed some basic models, but they are struggling to go to the next level, like as I asked. So what
Madam,
are your
in that
suggestions, sir?
in that case, please you have to tie up with any medical college who is willing to share their data regarding this particular aspect. Then you have to enhance your model and come up with a particular that is device based, that means hardware based device. Definitely it will be recognizable. So you can tie up with us experts, because as an engineer we doesn't know about that particular medical aspect. So we have to go
Yes,
for
sir.
collaboration with doctors and that particular field based experts to come up with the fine tuned devices. So you can just do one thing. You can collaborate with that is
Yes,
medical
sir.
people, and come up with the results. That is fine-tuned models, ma'am.
Sir, have you done any work related to that, sir? The
Uh,
diabetic retinopathy,
Actually,
because you
my
said
PhD scholar already I mentioned during my discuss, that is delivery. My student PhD scholar is currently doing that, but there are a lot of issues we faced during
yes,
this collaboration and everything. Even we don't have a proper setup to. Even he went to Madurai Medical College, and even here in SRM, CMC, everywhere else we approached. It's a proper procedure to get the data, so that
yes, sir.
we are struggled a lot. So
Actually, the cost of that real equipment is huge, sir. But if you want
yes,
to reduce that cost, so we have to go for
even
empty
okay, you
technologies.
can come up with IOMT kind of things, madam. Even okay, this is what a final outcome while you are merging IoT with that medical domain. But
Yes.
the thing is, The data and the fine tuning aspects, we don't know about, okay, what that up to what level we have to fix that range and everything. So that experts only have to suggest, sir, that getting that recommendation suggestion only is a matter.
Okay, sir. Thank you so much. You have given a very broad view about all the applications, especially towards the point of focus of this particular Atal FDP. Thank you so much, sir.
Thank you, madam. Thank you.
Excuse me, sir.
Yes, anything?
Sir,
Any other clarification?
only one query in the chat box, sir.
Please, okay, little bit louder because your voice is low, little bit, okay. Closer to the, yes, now it is audible, yes.
நீங்க படிங்க.
Hello.
Is there any security threats while transferring data using IOML?
Yes, sir, obviously it is there, sir. Even in that, but that is in that hospitals, they are not going to share the patient records, isn't it? So we have to be, that is, that patient records are going to be maintained in a confidential way. What disease, okay, that patient has, everything is okay, it is secret. In that case, if, it is, how they can exchange the data as it is. There are a lot of threats too for attackers. Even our Aadhaar data, even that is the few years ago, that is a couple of years back, I came to know that our Aadhaar database got hacked. If it is going to be get hacked, then you see, okay, that is imagine what will happen. So it is definitely we did a security aspect in that case. That's why hospital, that is that the data entry informations are not connected in the internet. That is going to be a separate device, that is the dedicated server which is dealing that particular hospital based information. Nobody is sharing, isn't it? So that is the separate domain. It is dealing everything. Only that that is their that is network alone is going to be accessed. It is not possible even single data it will come out of within that network. So there is a threat also is there. So it is not okay, it is distributed form which is kept. It is completely centralized and completely secure. Any other queries? Any other queries? Any other clarifications?
Again, there is a query in the chat box, sir.
Hmm.
Any other data set is available for any syndrome, sir?
Syndrome, actually, my student only gather the data set, sample data. We prepare the data. Once he is going to get complete his research, we are ready to circulate the data in open manner. That means publicly. Till we are not in a position to circulate, because we have to check its stability. Even is it that the data is behaving normally or abnormally. We are testing, under testing, okay, we are keeping the data. Once it will be okay, stabilized, definitely we are going to circulate in a public domain. It is not available. Sample records are there, you can access. So any other clarifications?
Okay, sir. No queries, sir. So thank you very much for your informative session on the topic precision healthcare through AI and deep learning, sir. Thank you very much, sir.
Thank you. Again, I would like to thank the organizing committee for giving this great opportunity. It's a time is too short, so I'm covering everything in an okay this a short time span window. Further, any clarifications or any research collaboration, I welcome your collaborations and everything. Thank you for patient listening. Have a happy learnings. Thank you very much.
Thank you very much, sir.
Thank you. Thank you very much.
Thank you, sir.
Now.
Thank you, sir.